What's up folks, this is JD with Red Barrel Skis. Today I want to show off a new software tool I've been working on. It's a CAD and CAM application for ski and snowboard builders. The first screen that pops up gives you the option to open an existing design or start from a template. If you select a template, you can adjust its length and it will scale all of the widths and thicknesses accordingly. On the main screen we have three shapes. On the far right is the ski or snowboard's base. In the middle is the mold, which gives the ski its camber, and then on the far left is the thickness profile. On the left side of the screen you have a collection of drop-down menus. In the upper right are Fit View and Update View buttons. Now let's look at the app's features. Generally speaking, you want to start at the top of these menus and work your way down. Hitting the Show Points button in the View menu displays the Bezier curve points and handles that make up all of the curved sections of the shapes. The base shape is a Bezier curve mirrored about a vertical centerline. You can show its dimensions by hitting the Show Dims button. As you can see, the ski here did scale to that dimension I put in on the startup screen. There's some ski stats that get calculated in the background. You can show those by hitting this Show Geom Stats button. And a helpful tool here is the interface shortcuts that give you kind of reminders how to be able to adjust the tangent handle behavior for all the control points, as well as some other on-screen tricks. Control points are all these bigger points out here, and their tangent handles are the little red ones connected by those lines. You can lock the tangent handles vertical with respect to one another by selecting the control point and hitting V. If you hit H, it'll lock the 2 points horizontal with respect to one another. And if you hit L, it'll unlock the points and make it so you can create a sharp corner. If you want to go back a few moves, you can always hit Control Z. For some more abstract design needs, you can hold down Control or Command on a Mac and then double click to create these little virtual points. When you select any 2 points, it creates a line and a dimension between them. Hitting D locks that dimension. For points or control points, when you select 2 and hit I, it will lock them vertically, and O will lock them horizontally. Selecting 3 points, it automatically draws a circle and gives you the radius. So yeah, you can also do all sorts of fun and kind of funky stuff when you play around with all the different points and locking and spinning them around one another. If you double click, you'll add a point to the main base shape. If you hold down C and double click, you'll add a point to the camber shape. And if you hold down T and double click, you'll add a point to the thickness profile shape. You can use box select to select a few points and then just hit the delete key to get rid of them. Now there's this nifty feature built in that is kind of meant to imitate the turning radius. It just draws a circle between these 3 kind of standard control points. And it kind of gives you a reference point for a very traditional like curved ski. It's all designed with lines that are kind of slightly transparent, so you should be able to kind of tune. If you're going for more of a carving ski, you probably want to follow that line a little closer, and if you're going for more of a buttery or playful, ski, then you probably won't follow it quite so close. There's a stiffness plot, and this is derived from the thickness and the width of the ski, and a couple sliders we'll see a little later. Now the math isn't perfect, I guarantee it, but it kind of gives you a decent idea of just generally speaking what the stiffness per unit length of the ski is. Powder ski versus a carving ski probably are going to have pretty different stiffness profiles. The remaining buttons up here in the view menu are kind of helpful for later. The CNC stats help you figure out where your shapes are in space when it comes time to locate them on your machine. And the global coordinates are for capturing the standard shapes and other kind of debugging purposes. Now let's check out the Layup tab. It controls all of what I call the derived shapes, shapes that are based off of this main base shape but not control point driven. You derive them with these scroll boxes. So the first shape I want to look at is the edge and the base. If your ski design includes an edge that doesn't wrap all the way around the tip or tail, you can inset it into the base with these two layers. You can define how far away from the tip it is and how thick of an edge you have. The next layer up in ski construction is the core, which has sidewalls on both of its sides and then tip and tail spacers on both of its ends. Basically kind of like a core of wood wrapped with a plastic bumper. For the seam between the tip and tail spacer and the core, instead of just having a straight line, I added functionality so that you can create interlocking shapes, kind of like a dovetail. It's similar to how the base works, where you have, control points and drag handles, and you can click all the different keyboard shortcuts to manipulate how the drag handles work, and then everything's mirrored about a vertical center line and all that kind of fun stuff. So here I'm just going to show off how you can create a dovetail joint between them. One feature worth mentioning too is that these points are still active even if they're hidden. So if you want to do some micro adjustment, you can just hide the points and continue to drag the invisible points around. The last shape in this group is the shell, which is just a combination of the sidewalls and tip and tail spacer in case you're going to do something like cast polyurethane sidewalls. When I'm designing a ski, I usually try to adjust these lengths relative to the camber, and so I don't really like it when my seams end up right on my contact points with the ground, so I like to move them up and down a little bit and adjust accordingly. The next handy dropdown provides you some fields that enter in some data for your layup that ultimately gets pushed into this report that you can export, this little like PDF that you can generate. Let me put a quick one together and let's take a look. Yeah, so here we go. This just has each of the shapes with kind of some general stats, and then all of the fields that we just entered, and then a few quick dimensional drawings too. Let's check out some of the other types of exports you can do. As a great starting point for any graphic generation, you can export an SVG or DXF and import that into programs like Inkscape, and DXFs are almost more like mechanical based drawings that can go into other types of CNC control software. Let's take a look at what gets exported when you do an SVG though. It's pretty neat. You get not only the base shape, but you get all of the shapes. So here you can see how I can click and drag each of these individual shapes around or delete them. Down here we've got our shell, our tail spacer, our core, each individual side wall. Not sure why that happened, but we'll just ignore it. The tip spacer, the individual edge shapes, and then the base shape, which has that edge notched out. So you can see it's got that little inset right there. And then this final shape is the base, which is just a great place for starting your graphics, since you can use it to derive the graphic from and get a real good scale and placement and all of those fun details. The STL export is kind of a fun feature where you can just export an STL and 3D print it. I've been having way too much fun recently 3D printing little mini ski designs. Now, back here in Ski Designer, we can take a look at the mold dropdown. It's a very simple one. It just has a few sliders that adjust the gap between the upper and lower mold. It adjusts, you can kind of see how it scales the gap in a kind of unique way too. So it keeps those two curves essentially like parallel to each other. And then you can control the number of holes drilled for aligning different slices in the mold and their placement in kind of a rough way. Pretty good chance I'll refine this as time goes on. The next menu down is the 2D appearance. So in this menu, you can actually show two skis side by side. You can load graphics from your computer to visualize on the top sheet of the ski. And you can move those graphics around left or right, up or down. You can scale them. So just a nifty tool for graphic visualization. Now, the 2D and 3D visualizers kind of work hand in hand, where if you're showing two skis in the 2D, it'll show two skis in the 3D. To flip and spin around the 3D ski, you right-click your mouse and drag. You can adjust the mouse input settings using the setting menu at the top. You can adjust the lighting on the ski since, subtle curves. It's kind of nice to be able to adjust the lighting characteristics with the sliders here at the bottom of that menu. And you can snap to different 3D views or adjust the 3D view with the scroll boxes and the buttons. There is a little background behind the 3D ski that you can change the color of, change the shape of, and just hide altogether if you want to. The 3D ski's just kind of generic color can be adjusted as well. The 3D ski can be displayed as shaded or shaded with edges. That's kind of like your Grand Theft Auto view looking style. You can also do a frame style view or a graphic view. Now, I do want to warn you, if you use the graphic view, it's going to bog down your computer kind of a bit. It's a little bit processor intensive, so if you're running this on a computer with not a tremendous amount of processing power, this might be a bit more choppy and less satisfying. There's a few default 3D views, and you can even save your own custom 3D view. This button pulls up the mouse input settings. And now for the CNC portion. When you expand this menu, a whole CNC toolpath preview window opens up. Let me just hide this graphic real quick, speed things up. You can snap your toolpath to different view angles and recenter and scale it with this little drop down. And this drop down gives you the buttons to select what shape you want to create the toolpath for. And as you can see over on the right, it's going to highlight the shape corresponding to that button. In this drop-down menu, you can basically generate a preview of the machine's work area and verify that your toolpaths are going to fit in the machine that you have at whatever your availability. You can manipulate the toolpath preview similar to how you manipulate the 3D ski with a right mouse button click. However, you have to have your mouse inside of that little window for it to know that you're trying to talk to the toolpath preview. And here in our final dropdown, we have the tool path parameters. Here you can adjust the feeds, the depth of cut, the number of step downs, and all the other little handy adjustments we like to make for our CNCs. If you click this depth from core profile, it actually generates more of like a 3D toolpath shape that follows the perimeter of whatever shape you pick, but then for depth, it uses the thickness profile. You can kind of see how it bows up a little bit in the middle right there. And you kind of need to click that button every once in a while if you want the preview to update. The ramp entry gives you an angled approach to your toolpath. This one's kind of extreme because of our depth there, but that's the idea. And then duplicate toolpaths is for when you want to cut two at the same time. The operation pull down kind of further refines the type of toolpath you're trying to create. So online is if you're using something like a drag knife for cutting out a base. Outside is maybe in case you're using an end mill for cutting out a core. Pocket is for removing a bunch of material from an area. And then boring and heel core boring are specific to the mold and are how you can cut the holes in the mold. So you can see here, since I've clicked the outside toolpath, when you zoom in on the shape it's defining, that yellow line, which is the actual toolpath, is outside of the ski's shape. And yeah, for pocket, it's going to remove that full area of the inside of the shape. Here's the boring type toolpath. So you can see the kind of plunge and circle, or the helical bore has more of a helix going down. And then the final step is just essentially to generate your G code and then hit save G code and save it off into your computer somewhere. Now let's jump back and take a quick, sanity check look at our G code. So once you generated some G code, you can open it up in your preferred machine controller. I like Universal G Code Center because it's free and open source and it works on a Raspberry Pi, but there's quite a few different options out there. My approach to this kind of sanity check is just to go row by row, inspect it for anything that I think looks unusual, any kind of weird typos or any grammatical errors. But then also, if you highlight it row by row in this software, it will kind of highlight that portion of the toolpath in the preview pane over on the right. So I usually just go through and I hide all the toolpaths, and then I highlight down and just watch it go through the operation. And then I'll usually jump all the way to the very end and just kind of make sure that when it returns from its very last toolpath to its home, that it isn't going to crash into anything. So there we go. That's Ski Designer. And I hope for it to be an open source tool that this community can grow and develop, and something that we can use to avoid the complexities of commercial CAD systems and bring, digital design from out in space back down to Earth. Thanks for watching. Hope to see you next time. Peace.